Okay? On Thursday, we covered the concept of the mole. Okay? The mole is this unit of measurement, okay, that tells us how much of something we have in terms of a very large representative number. Okay? That very large representative number is 6.02 times 10 to the 23. That is the number of particles in a mole. Okay? And it doesn't matter what I have, okay, whether I have atoms of gold, molecules of water, okay, that is how many I have in a mole. In the same way that it doesn't matter whether I have donuts or eggs, 12 is still a dozen. Okay, everybody with me there? All right. We then also learned that there is an equation that can be used to determine molar amounts. Okay, that is N equals little m over big M. Okay, N is the number of moles, M is the mass in grams, little m, and big M is the mass of 1 mole, or the molar mass, okay, of that material, which we calculate using the numbers on the periodic table. All right, is that ringing a bell from Thursday? Okay. And then on Thursday, we went through one of each type of mole equation question that I could give you. All right, so what we're going to do right now is go through again one example of each mole equation question that I can give you, then we're going to spend some time practicing. Okay? All right, so did everyone get those ones copied down while I was running everybody through the quiz? Okay, so those are the ones we're going to do right now. All right, so let's start out with mole equation question type 1. Okay, it's also number 1, but it's type 1. It's the easiest of the 4 mole equation problems. Okay, and I say easiest because you don't actually have to do any algebra. You just have to put numbers in the equation and punch them into your calculator. Okay, so this one wants to know how many moles. What part of the mole equation is moles? N. Right. Okay, so, okay, guys, you can always write this. If you recognize that it's a mole equation question, write that. You'll get a mark for it. Okay? Then we need to write down our givens. Okay, N is the question mark. They're asking how many moles. Okay, they also tell me that it's carbon dioxide. All right, so carbon dioxide is CO2. What do I need to calculate about CO2? I need its molar mass. Okay, so to get the molar mass, right, I go to the periodic table and I see that the molar mass or atomic mass for carbon is 12.01. Okay, how many carbons in this compound? 1. Okay, there's 1 carbon in this compound. Okay, there's no number besides C, so I just write 12.01. How many oxygens in this compound? 2. So I'm going to go 2 times the molar mass of oxygen, which is 16.00. Okay. So if I put those numbers together, I should get 44.01, I believe. Okay, what are my units? Grams per mole. All right, and then the last thing they tell me is I have 150 grams of carbon dioxide. So they give me little m, 150 grams. Okay, so I need to get n. Well, good news is my equation is already set up to calculate that. So all I have to do is plug in 150 for little m and 44.01 for big M. Okay, so I get a mark here, I get a mark here, and then 150 grams divided by 44.01 grams per mole. All right, what's going to happen to the grams when I do this division?
Cancel each other.
They're going to cancel each other up, and I'm going to be left with moles, which is what I'm looking for. All right, so when I do that, okay, 150 divided by 44.01. Okay, so we are looking at 3.41 moles. Okay. Questions on that? Anybody still need that up? Okay, type 2 problem. All the changes in a type 2 problem is, instead of asking for moles, they give them to me and ask for mass instead. All right, so they're saying, what is the mass? So what is the mass means I'm looking for little m this time. What is the mass of 26.5 moles? What did they just give me? Number of moles, which is what letter? N. Right, they just gave me N. Okay, of cobalt 2 bromide. All right, that's going to help me to get big M, the molar mass. All right, so cobalt 2 plus with bromine minus 1. All right, so when we drop and swap, we should get COBr2. Okay, so we got to calculate the molar mass of cobalt 2 bromide. Cobalt has a mass of 58.93 grams per mole. All right, and there's only one cobalt, so we only need that number. We don't need to multiply it by anything. Okay, and we need to add it to the mass of 2 bromines. Okay, bromine is 79.9, and there are 2 of them. Multiply it by 2, okay, and punch that into our calculator. 58.93 plus 79.9 times 2. All right, so there's our molar mass, 218.73. And grams per mole. Okay, I have N and I have big M. How do I get little m by itself?
Times by m.
Right, multiply both sides by big M. Right now I'm dividing by big M. Okay, rules of algebra say if you want to move something, do the opposite. I want to leave little m where it is, okay, and I want to move big M to the other side. All right, big M cancels from that side. Second rule of algebra, what you do to one side, you have to do to the other. I multiplied that side by m, so now I multiply this side by m, and I'm ready to go to solve for little m. Okay, that is the extent of the algebra that you will have to do here. Okay. All right, so big M, 218.73 times N, 26.5. Okay, so this is in grams per mole, and this is in moles. What's going to happen to the moles? They're going to cancel, right, and they're going to be left with grams. Okay, so we'll take our 218 and we'll multiply it by 26.5. Okay, so we are going to have 5,796.35 grams. Okay. Did we have to do anything like super complex there? We had to multiply 2 numbers together and we had to add some numbers together. Okay. There's nothing in and of itself, like any piece of this, that's really challenging. It's making sure you put the pieces together the right way. Okay. Anybody still need that one? All right, well, let's have a look at number 3 here. So in this one, it asks how many molecules are there. Okay, how many molecules is not part of this equation? Okay? That equation has moles, mass, and molar mass in it. It does not have molecules in it. All right? So, what we're going to need to do here is probably one extra step. All right? That extra step, anytime you see the word molecules or particles, this number is going to come into play. Avogadro's number. Okay? What does that number represent again? It is the number of particles in 1 mole. Okay? So if I'm looking for the number of molecules, and I know this is the number of molecules in 1 mole, if I can get this number, the number of moles, can I get the number of molecules? I can. Let me ask it a different way then. All right? I have 4 dozen donuts. How many donuts do I have? Don't say 4 dozen. I'm looking for an actual number. And I see people like whispering unconfidently, 48. Okay? And you should be confident it's definitely 48. Okay? How did you figure that out? You multiplied them, right? You know how many of anything there are in a dozen. A dozen is always 12. Okay? If you take the number of dozen you have and multiply it by 12, you will get the number of individual things that you have. This works exactly the same way. N is the number of dozen. This is like 12. This is always the number in a mole. 12 is always the number in a dozen. If I take how many moles I have and multiply it by how many molecules in a mole, I get the number of molecules. Okay? Everybody all right with that? That number, Avogadro's number, you will only ever multiply by it or divide by it. You will do nothing else with it. Okay? So here's what you need to ask yourself. If you're ever like, oh, I don't remember if I need to multiply by his number or divide by his number, ask yourself this. Am I looking for a number that should be really, really big or a number that should be more reasonable in size? Okay? Is the number of molecules of anything going to be a gargantuan number? It is. Okay? Molecules are tiny. So if I'm asked to calculate the number of molecules, I am looking for a huge number. To get numbers to be huge, is it more practical to multiply or divide? Multiply. So if I'm looking for a big number, I want to multiply by Avogadro's number. If I'm looking for the number of molecules, I will multiply by Avogadro's number. Okay? If I'm given a really big number, then I would use Avogadro's number and divide by it, okay, to get a more reasonable, smaller number. Okay? So that's going to be type 3 and type 4. Okay? In type 3, you're going to multiply by Avogadro's number. In type 4, you're going to divide. Okay? All right, so I'm looking for how many molecules. Okay? So I can write that down. Number of molecules is what I am looking for. Okay, what do I have? Well, I have the material. It says it's sodium sulfide. That can help me get big M. Okay. Sulfur is a -2, sodium is a +1. Okay. That's what our compound should look like. Now to calculate the molar mass, I have how many sodiums here? Okay, so 2 times 22.99. That's the molar mass for sodium. Okay, 22.99. Plus sulfur, 32.07. Okay. Okay, now I just have to put those into my calculator, and I will have the molar mass of sodium sulfide. Okay, 78.05 grams per have big M, and the other thing they told me in the question is something in grams. Well, something in grams is always little m, 29 grams. Okay, I have little m and I have big M. What can I calculate right now? N. Okay, even if you had no idea where to go after that, do it anyway. Okay, you get marks for it, so okay, that's what you can do right now. Do it. Okay, N equals little m, which is 29 grams, divided by 78.05 grams per mole. Okay, grams are going to cancel, and I'm going to be left with moles. Do I have a very small number of moles here? Do I have less than a mole here? I do, and that's okay. Okay, 0.37 moles. Now, something important here, guys. Keep all of your decimals until the very end, okay? We never round anything off in science until we get to the very final answer, okay? The final answer you can round down, okay, or sorry, round appropriately, okay? Round up or round down, depending on what's appropriate, right? But we never round until we're at the very end. I'm not going to write them all, I'm just going to abbreviate it and keep them in my calculator. Okay, so now I know how many moles I have. I'm looking for the number of molecules. This number is molecules per mole. Agreed? This is the number of molecules in 1 mole. This is the number of moles. If I multiply those two numbers together, will I get the number of molecules? I will. So that's the additional step in a type 3 question. Okay, number of molecules, okay, is essentially n times 6.02 times 10 to the 23. So we just put in our numbers. 0.371 with all the decimals from my calculator times 6.02 times 10 to the 23. Now, you may have forgotten how we enter that into our calculator. So if you have a Texas Instruments, so a TI, whatever number we're on now, 250, I don't know. Okay. So if you've got that, okay, you're going to take that number there, and you're going to multiply it by, in brackets, 6.02. You're going to hit the second function button, and then you're going to hit the comma. Okay, because right above the comma are the 2 e's. Okay, that gives you a little e there. That means times 10, and put in your exponent. The exponent is 23. Okay, close the brackets. Okay, did we get a giant number? We did, and we should. The number of molecules in this number of moles should be a huge number. All right, so our final answer here is now we're going to round this one to 2 decimal places. 2.24 times 10 to the 23. Okay, that's what this means here, the 23. Okay, so type 3 question has that extra step involving Avogadro's number. Yep. Okay, any questions on type 3? Okay, number 4 here. So this is a type 4 question. You can see in this question, I'm given a giant number. Okay, I got to get giant numbers under control. So what am I going to do with this number and Avogadro's number? I'm going to divide them on this one. Okay, so let's still write down our given, same as we always do. What is the mass? Okay, mass is little m, so I'm looking for that. They give me the number of molecules here, 7.2 times 10 to the 23. Okay, And they tell me that it is diphosphorus pentaoxide, E2O5. Okay, and that's all they give me. Okay, if I want to get little m, I want to get mass, I need big M and I need N. Right now, I don't have either one of those things. Okay, good news is though, I can get them both. So let's do big M first. Okay, how many phosphorus here? 2. So I'm going to go 30.97 times 2 plus, how many oxygens? 5. So 16.00 times 5. Okay, so we're looking at 141.94. grams per mole. Okay, I'm still missing N. Okay, I need N if I'm going to get little m. But here's what I do know. I know I have this many molecules, and I know this number, which is the number of molecules in 1 mole. Okay, so let me ask you this hypothetical question. I have 24 eggs. How many dozen eggs do I have? How did you do that? You divided them. You took the number of eggs you had and you divided by the number of eggs in 1 dozen. You went 24 divided by 12. You're going to do exactly the same thing here. You're going to take the number of molecules and you're going to divide by the number of molecules in 1 mole. Okay, you're doing exactly the same thing here. Okay, so we're going to calculate N. We're going to go 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. All right, so now if you're good at math, you realize that there's probably a shortcut that I'm not doing here, and if you realize it, good. If you have no idea what I'm talking about, that's fine. Okay, 1.196 moles is what I have here, which makes sense. If 1 mole is 6.02 and I have 7.2, I have a little more than 1 mole. Okay? All right, so 1.196 moles. I'm going to keep all those decimals in my calculator though. Okay, I now have N and I have big M. Can I find little m? Okay, what do I have to do with big M? Right, I've got to move it to the other side. I've got to multiply it over to the other side. Okay, so now it's over there. Now I know what I have to do. Okay, so mass is going to equal 1.196 moles times 141.94 grams per mole. All right, moles are going to cancel. I'm going to be left with grams. Okay, so I have 169.76 grams of diphosphorus pentaoxide. Okay, a type 4 question is probably a 5-mark question. You have a lot more to do in a type 4 question. Okay, so you would get a mark for your givens, you'd get a mark for calculating N, you'd get a mark for the mole equation, you'd get a mark for its manipulation, and you'd get a mark for your final answer, 5 marks. Okay. All right, if you're feeling really anxious or panicked, I understand. It's okay to feel that way. Understand, we have all week to work on this, okay? This is like your first or second day with the mole equation, and it can be a little intimidating, right? But trust me, there are only 4 ways I can ask you a mole equation question, and we're gonna go over them every single day this week, okay? It's just a pattern. Learn the pattern, and you're fine. Okay. All right, I'm gonna give you guys about a 5-minute break here, and then I'm gonna have you try a few of these on your own. Okay. In number 1, they're asking us for the number of molecules, and they're telling us the number of what? Moles. So they're telling us you have this many moles. We want to know how many molecules do you have. Okay? What do I have to do to solve any of the ones in question number 1? I want to go from moles to molecules. Is there a magic number that helps me do that? Whose magic number? The 6.02 times 10 to the 23, right? Okay. Last semester somebody said avocado's number. It's Avogadro's number, okay? It was good for a laugh, okay? So yeah, we need to use Avogadro's number, okay? 6.02 times 10 to the 23, okay? How do I want to use that number? I have the number of moles, which, as we can see, are all very small, reasonable numbers. I am looking for a really big number. What do I want to do? I want to multiply, okay? I just want to take, this is n. They're telling me n right now, okay? They're just giving it to me, not making me work for it, okay? They're telling me n and asking for the number of molecules. So all I have to do is take n and multiply by Avogadro's number, okay? Anytime you want to get the number of molecules, that is what you do. You take n and you multiply by Avogadro's number, okay? Always, always. That's the only way you're going to get molecules, okay? Is to multiply n by Avogadro's number. Okay, well, let's have you guys, oh, sorry, we should do this. Okay, so we'll take our 0.628 and multiply it by 6.02 E23. All right, so we're looking at 3.78 times 10 to the 23 molecules. So what would the answer to number 1 be? Sorry, to 1A, sorry, to 1A. Exactly. I have 1 mole of gold. Isn't that 6.02 times 10 to the 23, the number of particles in a mole? And if you went 1 times 6.02 times 10 to the 23, would you not get 6.02 times 10 to the 23? Right? 1 times anything is itself. Guys, here's the thing. For 1A, would it have mattered what material I put there? 1 mole of anything is 6.02 times 10 to the 23. In the same way that 1 dozen of anything is 12. Okay, works the same way. All right, please try 2D and 3D. Okay, for 2, you're looking for the number of moles, and for 3, you're looking for the mass. All right, so for 2D, okay, they tell me I have 100 grams, so they tell me what little m is. Okay, we're looking for the number of moles, so we're looking for n. And they tell me that it's N2. Okay, so how many nitrogen do I have? Oh, sorry, it's NaCl. That's why you guys are looking at me like I'm talking with. Okay, NaCl. All right, how many sodium do I have?
1.
1. Okay, so 22.99. Okay, how many chlorine do I have? 35.45. Okay, so 54.44. You know what? I shouldn't do things in my head. I should know better. 22.99 plus 35.45. 58.44. Okay, 58. Grams per mole. All right, so I've got M and I've got big M. Mole equation says I calculate, okay, N by dividing those two numbers. So all I have to do is go 100 grams divided by 58.44 grams per mole. Grams will cancel, and I'll be left with the number of moles. So 100, okay, divided by 58.44. Okay, so 1.71 moles. Okay. Now, just so you know, guys, the keys for these are in Google Classroom. So if you're wanting to check your answers as you go, okay, they're in the class work tab. Okay, and it's under other items, I believe. Okay, so key for naming, mole equation worksheets with keys. Okay, if you open that file up, okay, you've got the answers for all of them there, so you can check and see if you're doing it right. You have to read my chicken scratch, sorry, but yeah, it's all there. Okay, all right. Okay, so for number 3D, in number 3 we're looking for the mass. So in number 3 we're looking for little m. Okay, in number 3 we are told the number of moles. Okay, so they give us N and they tell us the material so we can find big M. All right, so let's find big M. We got magnesium, which is 24.31. There's only one magnesium there. Okay, plus 2 chlorines, 35.45 times 2. Okay, so 24.31 plus 35.45 times 2. All right, so 95.21 grams per mole. Okay, so we've got molar mass and now we've got N. So now we have to do a little bit of algebra so that we can get little m. So we're going to multiply both sides by big M, multiply these two numbers together and get mass. So that'll be 95.21 grams per mole times 36.8 moles. Okay, so we should get 3,503.73. What are my units? Oh, I wrote that wrong. 3,503.73. What are my units? Grams, right? Okay. Questions on that one? Okay, so keep going there, guys, on 4 and 5. And then I'd also like you to answer, doesn't require any math. Answer and explain to me number 7. Again, requires no math. Okay. All right, so on number 4, we're looking for mass. Okay, so we're looking for M. So this is what type? Is this 1, 2, 3, or 4 type question? It gives me the number of molecules, wants me to find mass. It's a type 4. Okay? So on a type 4 question, remember, you're given the big number. Okay? You need to make it reasonable. So what are you going to do with the big number? Divide it by?
The 6 number.
Right, avocado's number, right?
Yes.
Yes. Okay, so we're going to do that. Okay? Now, do I actually really need to punch this into my calculator, or can I look at that and go, that's half a mole? Right? If 1 mole is 6.02, this is 3.01. Okay, it's half. Okay, so I'm just gonna, yeah, I can do that, but I do it in my head. Okay, so N is gonna be 0.5 moles. Okay, it's still a type 4 question. If it was any other number, I'd have to put it in my calculator. Okay, so I know N, 0.5 moles. Okay, and I know that it's copper. So might just have to look up the molar mass of copper here. Okay, 63.55 on my periodic table. Okay, well, N equals little m over big M. I want little m by itself, so I'll multiply both sides by big M, okay, and take my 63.55 and basically multiply it by 0.5. Okay, so 31.78 grams would be my final answer for that one. Okay? All right, number 5. What type? You're looking for the number of molecules, so that's type 3. Yeah, this is a type 3 question. In a type 3 question, we're trying to get a really big number. What am I doing with avocado's number? Multiplying by it. Okay, so I know I have 1,000 grams, okay, and I know that I know it's water. Okay, so if I'm trying to find the molar mass of water, that's 1.01 times 2 plus 16 for 18.02 grams per mole for big M. Okay, so if I'm going to get number of molecules, I need N. So that's little m over big M. Okay, so that's 1,000 grams, because that's what they told me. Okay, divided by 18.02, the molar mass of water. There's my number of moles. N is 55.49. Okay, what do I do with that number now? I have N. I need to get the number of molecules, which is a big, big number. Multiply by Avogadro's number. Okay, so we take the number we just calculated, multiply it by Avogadro's number. Okay, so we got 3.34 times 10 to the 25. What are my units? Molecules, yeah. Okay, don't pack up. Let's talk about number 7. Wording on number 7 is super important. Which contains more atoms? A mole of iron or a mole of oxygen gas? Actually.
I just took the answer.
Oh, okay. What is it?
That a mole of any element contains the same number of atoms. I think.
You're right in that
Now
statement.
that you give me that look.
You're right in that statement. There's nothing wrong with that statement. But in the fact of this question, it doesn't ask particles. It asks specifically atoms. Iron comes like this. How does oxygen come? O2. If I had a mole of oxygen, I would have twice as many atoms. I'd have the same number of molecules of oxygen as I have atoms of iron. Okay? Something to think about. A little bit. Okay, see you guys tomorrow. Good work today.